Good day to you all and welcome back to Polytronics. My name is Fatima Garba Yusuf and we're going to try and solve an indirect question. So here we have an aluminium bar has a reduction in area of 62% and breaking strength of 28,000 psi pound per square inch based on the original design area. Then we're asked to calculate the true stress and true strain just prior to fracture. So from this question, you can see that we were not really given any specific values of length or load or area or anything like that. Instead, we're given reduction in area of 62%. We're given breaking strength of 28,000 pound per square inch, and we're told that it's based on the original design area. So of course, this is an indirect question. And usually we'll notice that in the previous examples that we solved, even though the questions were not entirely direct, meaning we're not given original length, original area, final length and final area, but it was a bit easier because at least we had the area values, and with the area you can calculate your way to stress and your strain. But in this case, we're only given reduction in area. So this means that we're going to find a relation that will give us a ratio of the original area to the final area. A simple way to do this is by saying, okay, let's start our solution by saying, since we have a reduction in area, this implies that the final area is less than the original area. And by this, since we were told that the final area was reduced 62%, it simply means that our final area is actually equal to 100 minus 62% of our original area. That is, by the time the area got so reduced, 62% went away, leaving how much? Leaving 38% of our original area. That is, our final area is equal to 38% of our original area. That is also the same thing as 0.38 of our original area. So anywhere where we are required to use maybe the ratio AF over AO or AO over AF, we simply use this. We use AF in terms of AO, and that will give us our fraction. Even though we don't know what the original area is, we don't know what the final area is. As for the breaking strength of 28,000 psi, that is actually talking about our stress. But which stress? Is it the engineering stress or the true stress? Now, because they said based on the original design area is actually this, and that's the value we use to calculate our engineering stress. So this simply means that this value is our engineering stress. So you see, with this we can say that our engineering stress is equal to 28,000 psi. Now we're asked to calculate the true stress and the true strain. Now how do we do that? We can recall that when we're calculating or when we're deriving the formula for true stress, we said that we can calculate true stress either by saying it's equal to F over our final area, or it can be simplified to be this is our true stress. True stress is equal to the force divided by the final area, or the engineering stress multiplied by your final length divided by your original length. But here we're not given the force, we're not given the final area, we're not given the LF over LO, we're not given LF, we're not given LO. But what we know that we can get AO over AF. How? By putting AF in terms of AO. So this implies that this will give you our AO will remain the same, while our AF will be 0.38 AO. So you can see this AO will cancel this AO, leaving us with 1 over 0.38, right? And this can be simplified to be simply our engineering stress divided by 0.38. So this implies that our true stress now will just be equal to our 28,000 psi divided by 0.38. And what does that give you? Even before you calculate this, you can be able to discover that this will be a very large value because the area was reduced very much, so meaning it was lengthened a lot. And of course, we're even told just prior to fracture. This is implying that the specimen was stretched so much that it's actually reached the fraction point. So 28,000 divided by 0.38 will give you 73,684. 73,684.21 psi. As for the true strain, we're not asked to calculate the strain here. So the true strain can actually be calculated with or without the engineering strain. So in this case, our true strain is going to be, you can skip the integration process and just know that our true strain is actually the length of your final length divided by your original length. But in this case, we don't have our length, so we'll use the length of our original area divided by our final area. So we'll just switch it up. Now here again, we are going to use that ratio, length of AO divided by AO into 0.38, right? So our AOs will cancel each other, leaving us with length of 1 over 0.38. Now note that in this place, if we had actually calculated 1 divided by 0.38, it will give us a value, and then we could multiply that value to our stress. But there's every tendency for us to have a different value from this, because by the time you divide 1 divided by 0.38, it's going to give you a decimal, and you'll most likely approximate that decimal, and that will introduce error into your calculation. So it's better to minimize the number of steps you are undergoing, so that you don't introduce approximation, or you should minimize your approximation so that you don't introduce errors. But here there's nothing we can do. We have to divide 1 divided by 0.38. 1 divided by 0.38 will give you 2.63157, and so on and so forth. So your true strain will be equal to length of what? 2.631, let's say 6. Leave it at this. And what will that give you? Length of 2.6316 will give you 0.9675, and 0.9675 0.96759 will actually be approximated to 0.968. It doesn't have a unit. And that's it. You've already calculated your true stress and true strain. Now if you were asked to find your engineering strain, what you'll need to do is use that formula where we talked about changing your engineering strain to the substitute of the formula by taking the exponential and so on and so forth. But in this case, we're not asked about that, so your answers will be your true stress to be this and your true strain to be this. Thank you very much for watching. See you in other videos on different topics. You can feel free to explore the channel to watch some other tutorials and different topics and different subjects. Thank you very much for watching. See ya.